In this video, I'm going to talk about how to evaluate a simple formula, and I'm going to look at three formulas that are really common to see in a lot of math classes, and we're going to use those formulas as examples. So before we do that, let's talk about what it means to evaluate a formula. So let's look at this formula just for an example, d equals RT. So that stands for distance equals rate times time. So it's a mathematical statement showing the relationship between distance, rate, and time. If you know all of the values except one of them, then you can plug in what you know and then solve the equation to find the missing value. So in this case, distance equals rate times time. If I knew two of the variables out of the three, then I could solve for the third one. And it doesn't matter which one I don't know. I can solve for any of those as long as I know the other two. And so we call this process solving for the missing variable. I sometimes also like to call it plug and chug because I'm plugging numbers in, and then I'm using my solving techniques to get a variable. And so let's look at example 1. So we're going to continue looking at distance equals rate times time, and for part A we're given some values. So I always start by writing down my formula. So distance equals rate times time, d equals RT, and then I'm going to identify what's given. So rate is 55, so I'm going to plug that in for R. Time is 3 hours, so I'm going to plug that in for time. And then we don't know what D is. So that's what I'm trying to solve for. And in this case, all I have to do is multiply. So 55 times 3 is 165. And then if we're wondering what the units are, because it's always good to write our units with the answer, just look at what's given. And since the rate is given in miles per hour, the distance is going to be miles, since that's the distance that miles per hour uses. Okay, so for B, we're going to do the same thing. We're going to write distance equals rate times time, and then I'm going to plug in what I know again. So rate is 25 miles an hour, so I'm going to write that down. So say you're going 25 miles an hour, and then the distance is 32 miles, so you travel for 32 miles. What is T? So I don't know what T is, so we're going to solve for T. Now, if we want to get T by itself, then we're going to undo that multiplication of 25. So I'm going to divide both sides by 25, and the 25 divided by 25, that's just 1. And so that's how those cancel out. And then we're left with a T on the right-hand side, and then 32 divided by 25 on the left, and we get 1.28. Now, the directions say round to the nearest tenth if needed, so we could also say T is approximately 1.3, just following those directions. And then in this case, time would be hours, since the rate given is miles per hour. So we're going to be consistent and say that the time is hours. And then for C, I do the same thing. So distance equals rate times time. The distance given is 73. Okay. Time is 4 hours. And then the rate, we don't know. So I just write down R. And this is similar to the one above, although notice that the number is to the right of the variable. If you want to rewrite this as 73 equals 4R, you can. Oftentimes in math, we have the coefficient of the variable, the numbers, and comes before the variable, but it doesn't matter. You could have left it the other way too. And so I'm going to divide both sides by 4 because that undoes the multiplication of 4. And so my answer is just going to be 73 divided by 4, and I end up getting 18.25. And so that is my rate. Since I'm asked to find round to the nearest tenth, I'll say the rate is approximately 18.3. And I'm going to say miles per hour since we were given miles and hours. So miles per hour. In example 2, we're going to look at the formula for volume of a rectangular prism, which is basically like a box. Think of like a cereal box as a rectangular prism. If you want to find the volume of something like that, you just take the length times the width times the height, and that'll give you the volume. So in this first one, we're given length, we're given width, and we're given height, so we're just going to plug those all in. So I'm just going to write down my formula, volume equals length times width times height, and I'm going to plug them all in. So we've got 2 for length, we have 1.4 for width, and then we have 8.1 for height. And then I just put those all in my calculator. and then that gives me the volume. And in this question, I'm not given any rounding instructions, so I'm just going to write down the entire number, 226.8. And in this case, all of those measurements are given in inches, since we see the symbol right here means inches. So when we multiply in inches by inches by inches, then our answer is inches cubed, or cubic inches. So the volume is 226.8 cubic inches. And so then the next one, I'm going to do the same thing. So volume equals length times width times height. I write down the formula, and then I identify what I know and what I don't. So it looks like the width is 5.1, so I'm going to plug that in. And then it looks like the height is 4.3. And they give us the volume of 149.124. So I'll write that down. So 149.124. I don't know what the length is, so I write L there. In this case, I like to kind of tidy up, clean up the right-hand side before getting rid of those numbers. You could divide them each one at a time to get rid of them. I like to multiply them first, so I'm just going to do 5.1 times 4.3, and I get 21.93. And I'm going to write, I'll leave the L there, but I'm going to rewrite that in a second, because I like to write the number, the coefficient, before the variable. So I'm going to rewrite it. 21.93L equals 149.124. And then I solve by getting rid of that 21.93, and I'm going to do that by dividing, because that's the opposite of multiplying. So those go away, and then I'm just left with, I just have to plug this in, 149.124 divided by 21.93. And I'm left with an answer of 6.8. And since I'm solving for L, and all of the other dimensions are inches, we can assume that this is also inches. And I also know that because our volume is in cubic inches, so it means that I'm missing another dimension in inches. So 6.8 inches would be the length on a box with a volume of 149.124, and those with the width and height that's listed. In this last example, we're going to look at the formula that gives us the average of a list of numbers, and all the X's on the top, those are just the individual data values, and the N on the bottom just stands for the number of values in the list. So for part A, we want to find the average of 2, 5, 6, and 8. So those are kind of like my X1, my X2, my X3, my X4. You don't have to write it like that though. You can just add those. Those are all going to be added in the numerator, and you're going to divide those by the number of values. So in this case, N is going to be 4, since there are 4 data values. Now, if you have a calculator like I do, you can press the fraction button, the N over D button, and you can enter it in just like I have here, and press the down arrow to put the 4 in the bottom. Okay, and we get 5 1/4, which is the same thing as 5.25. You could, just to show you, so 5 1/4 or 5.25. If you're rusty with fractions, this calculator even has a fraction to decimal conversion. So you can hit second and then that fraction button again, and it'll give you the decimal. Keep in mind, if you don't have this calculator, you could also just add 2 plus 5 plus 6 plus 8, enter, divided by 4, and you could do it that way. So just use the division key. And so for B, we're going to find the average of 2 and 5. So I'm just going to do 2 plus 5 divided by, in this case, N is 2 because there are 2 data values. So we're going to divide those by 2. So I'm just going to do 2 plus 5, enter, divided by 2, and I get 3.5. So the average of those numbers is 3.5.